as a way of introduction, the Intelligent Transport Taskforce, the Smart Cities Council, is a task force of interested transport experts. We have historically produced documents such as the Code of Digital Transformation of Transport, which is available on the Smart Cities Council website. We're always looking for initiatives and ideas and blueprints to add value. I guess the value proposition from Smart Cities Council's perspective is we bring together a think tank of experts, whether it's government, private sector, regulators, startups, technology firms, practitioners, consultants, into one umbrella and one platform, and that really allows fluid discussions, knowledge, I guess, enhancement exercises, and really creates an environment where we can come up with creative ideas. Today's panel discussion, an extension of the work that we've already done in the blueprint paper. In that, we summarize a lot of different things, including an overview of digital twins, types of digital twin projects, implementation frameworks, regulatory considerations, implementation roadmaps, and barriers and risks. Today's safer, more sustainable mobility. We've got a very power-packed expert lineup today from Australia and New Zealand, covering a range of different topics, including the impact of changing demographics, evolving transport behaviours, environmental priorities, and embedding that into the digital footprint as well in terms of predictive modelling, GIS applications, digital compliance, and really looking across modes, as Robin's mentioned as well: roads, buses, light rail, high-speed projects, pedestrians, services as well, because transport really has such a big remit. On top of that, obviously, there are some broader issues such as decarbonisation, innovation, electrification, ISO alignment in terms of compliance, that also need to be considered. And of course, with major projects such as Parramatta Light Rail, are very important in terms of ensuring critical aspects of delivery. So without much further ado, maybe we can just go around and give a brief introduction first from our panelists. Pete, do you want to quickly start off? We'll go around the room.
Yeah. Hi, everyone. I'm Pete Klestoff. I'm the manager of economics and demographics at Transurban. And yeah, today I'll talk to you about some of the things that we're doing tech-wise across the company, but then also doing a bit of a deep dive into what the cities of the future are doing and some of the smart tech that we're employing to figure that out.
Yeah. Megan?
Hi, I'm Megan Gregory. I'm a principal transport engineer at SYSTRA. We're a consultancy in Christchurch, New Zealand. We do work all over the country in transport engineering and planning. The whole gamut of what involves, but specialising in walking and cycling, active modes, and also traffic signals, roundabout design.
Yeah. Matt?
Hey, how you going? Yeah, Matthew Jednick. I'm the digital engineering lead at GHD in Sydney. I've worked on some of the major projects around Sydney recently: M6, M12, Parramatta Light Rail, and currently again Parramatta Light Rail for the next stages. So, yeah.
Fantastic. And last but not least, Maud.
Thank you. Hi, everyone. So I'm Maud Leruste. I'm also based in Sydney. I'm currently managing what we call the network planning and optimization team here in SYSTRA. So we do a lot of ranges from transport planning, but mostly rail planning and operations / operation modeling. So we use a lot of tools. So I think, that's what I'm going to be showing you today, is how to efficiently use the tools and make sure we deliver the right outcomes for the customers.
Yeah. So very excited. We've got a very diverse panel and a lot of interesting case studies and real life examples to go through today. So the way that we'll run it is we'll do 10-minute presentations each, and then we'll have a panel segments and then closing remarks at the end. If anyone has questions along the way, feel free to put them in the Q&A part of the team's chat, and we'll endeavor to answer them as soon as we can, either throughout the presentation or right at the end. But yeah, without much further ado, I'll hand over to Pete, who will go first around the demographic aspects.
Great. Thank you, KC. Hopefully everyone can see my screen. There we go. Sorry, it's all okay. Is that fine for everyone?
Yep.
Okay.
Yep.
Cool. All right. Yeah. Thank you. Thanks, everyone. Yeah. As I mentioned, I'd like to talk to you a little bit about Transurban as a company, but then also some of the work that we're doing around trying to forecast the cities of the future and how that sort of works, and around, you know, trying to design and plan infrastructure. So for those that may not be aware of Transurban, we're I think either the biggest toll road operator in the whole world, or at least one of. We operate 22 toll roads across Australia and North America. We've got over 11 million customers globally, broken down between 7 million in Australia and 4.3 in North America. And that, at a very crude level, is about 1 in 4 of the Australian population, who's basically one of our customers. A stat that we uncovered recently was that about 30% of the Australian population lives within 15 minutes of our roads. So yeah, we're you know, very much an important fabric of infrastructure in our cities. I think more interestingly to this conversation is, I think people don't often think of technology and smarts when it comes to roads and motorways, but for a company like us, technology and data is literally everywhere. You know, we're processing 2.5 million customer trips each and every day. We've got, up until the latest corporate report, we've got 1.6 million people using our new rewards program. And, you know, if we think about that just from a data perspective, that's tens and tens of billions of rows of data that's coming in all the time. I'll give you a bit of a run through of some of the tech that we've deployed internally as a company. But I mean, just one sort of example here is how we're sort of blending smarts with the customer is our app at the moment, which is constantly getting upgraded and improved. One of the things that our team has done internally here was that we wanted to show the customer how much time they're actually saving when they use one of our roads. And we've deployed, you know, a lot of internal data and technology to basically return travel time savings back to the customer to show the value that we're providing, but also things like carbon footprint as well, where, you know, those that are interested in knowing how much they're saving in terms of using highways over sort of the stop-start when you're in congested traffic is important. And obviously for the big trucking companies, that's important as well. Yeah, a bit of a around the grounds as to some of the technology that's being deployed. We're using increasingly a huge amount of AI across the company, whether that's to detect vehicle incidents and crashes and congestion, to new AI chatbots, which is found to be hugely popular. We're using digital twins and LiDAR to manage some of our which doesn't sound like a lot, but I read recently that over half of the energy in our tunnels actually comes from managing these fan systems. So little things like that. Just in the news recently, Toyota's partnering with us about connected autonomous vehicles and plugging into our assets. And what that means is it's almost like an ability to see around the corner, is how it's being described to me. Yeah, and a whole bunch of other things as well. This map on this little image on the right is some vehicle classification work that we've been doing, not just to actually know things around sort of tolling, but it's actually part of our prediction side of the company, where we're trying to actually figure out what type of trucks and cars they are and where are they going and where are they traveling to and from. So it forms part of our economic model. But yeah, so there's obviously technology everywhere on our assets, but the work that I do and the team that I'm in, we're actually much more about peering into the future. And we want to know sort of the future of our cities, because if we're to have an understanding of the future, we're able to better provide value with the motorways that we're building. And one really good example, I'll try to zoom in a little bit here, but this is a map that was in the Daily Telly a few weeks ago that I made. Basically, what you see here in the green is how far you would be able to travel in about 45 minutes if you lived in Parramatta, and that was in around 2016. So you could go all the way to the green in 2016 in 45 minutes, whereas in 2024 you could actually travel all the way to the blue in 45 minutes. So, and this is basically largely due to WestConnex, which has come in and it's made travel around the entire network a lot easier, particularly going into the east and getting into the city. So yeah, you could obviously go a lot further in 45 minutes, but I think the clincher here is that catchment has grown by 700,000 people. So if we want to talk about value and trying to understand our cities, I think that's a pretty clear case that, you know, we're able to deliver the right infrastructure when it's done smartly, because we're able to get people further in the same amount of time despite the city growing as the way it is. So it's often assumed that, you know, Transurban, we're all about measuring cars and trucks, but actually it's about the people who are driving the cars and trucks. It's actually the people, and people don't, I think, when they look into Transurban, don't realise that we've actually got a pretty good understanding of people within our cities, where they're living, where they're working, and how they're getting around. And, you know, my role in the economics and demographic space is all about really trying to keep on top of that, where that gets deployed into our models as well. So just to give you some headline numbers, I mean, over the past 20 years, so 2004 to 2024, but then also out into 44, you know, our cities are basically doubling in size. You know, so Sydney is going to be going from 4.2 million to 7.3, Melbourne 3.6 to 7.4, and Brisbane 1.8 to 3.9. So it's a huge amount of growth. And maybe to just add a little bit of a better flavour to that, that's equating to, you know, 1,300 to 1,600 people moving into Greater Sydney every single week, up to 2,000 people in Melbourne every single week. That's what we're forecasting. And a growth that's going on, and obviously, just proof point that we need the infrastructure to keep up with it. This is just a bit of a visual as to where we're sort of anticipating a lot of that growth to occur. So, you know, maybe some of you have been reading in the news about sort of a bit of a suburbanization effect that's happened post-COVID. Also from like a property, house pricing type thing. People are looking to see whether they can buy property at a price they can afford. Well, we're certainly seeing those trends play out, and that's actually how we're sort of anticipating that future growth to occur. So I'll zoom in quickly on Melbourne. We're very much expecting huge amounts of population growth that's going to be happening in sort of the northern regions, and also out to the west and partly the east as well. So those sort of outer growth areas. Sydney, same story, a lot of growth around the northwest growth area. So Marsden Park, Kellyville, those sorts of areas, as well as the new city around Bradfield and the Western Sydney Airport. And then again, a similar thing that's happening here in Brisbane. We're down sort of in this Ripley Valley, Yarrabilba type areas. We're going to be seeing a huge amount of growth. So yeah, again, all showing that, you know, despite our efforts to try to get people to move into the city, the reality is that people are still moving outwards, and we need to make sure the infrastructure reflects that. So yeah, a bit more of a discussion about what the future holds from a technology perspective within the company. So at its core, where we're at as a company, and certainly on the economics and demographic side, is we're always doing a lot of measurements based on sort of, there's a lot of sort of aggregated data, things that are almost like a suburb level or slightly smaller than a suburb level, and we're blending a lot of data together to inform the future. But we're actually embarking on almost a future modelling program where we're basically in the midst of creating almost what we're calling a transport digital twin. So really trying to break down that aggregated data to disaggregated data. So rather than looking at things at like a block or suburb level, so to speak, how can we bring that down to almost understanding our city by the building level or by the individual or agent level? And this is just a bit of an example here of what would happen is that we've been developing systems where we're actually able to estimate the number of people within each building, and also not just that, the number of jobs and the types of jobs within each building as well. What that means is that if at Transurban, we're all about trying to figure out where people live, so like their origins, and also where they work, their destinations. So if we've got a really clear understanding of individual locations of where they work and where they live, we can connect those two together and get some really, really good insights and provide some really good value for money. So it's all about integration of a lot more real-time data to create almost these digital twins. Just a bit of an example on my side. This is the final slide. Just a bit of a proof point as to how we're sort of shifting to more of this sort of disaggregated data. This here on the left-hand side is some real-time construction data that we've been working with. And I've just coloured it by sort of residential, commercial and industrial. And I think it just shows and highlights, firstly, the scale of activity that's going on and the number of the amount of construction that's happening in Brisbane, but also sort of just where we're sort of seeing clusters of activity. So we know that industrial players love to be around Transurban's assets because they want to be able to get around the city faster. And we're certainly seeing this play out. So you're seeing a lot of industrial activity that's happening around our assets. But I think more interestingly here for me is actually we're seeing a lot of continued residential construction that's happening in the fringes. And I mean, if we're looking at just a high level view of sort of the road infrastructure around there is a question as to whether the infrastructure will be there to support that moving into the future, and what does that mean? On the right-hand side is just a bit of an idea of how we're measuring development activity, or where we're almost trying to do like a prediction as to the years after we get this construction activity. You know, if we're thinking 5-10 years into the future, where could we see development activity occur? And again, this is just a map of sort of Bondi Beach, and the areas that we've sort of highlighted around the train station of Bondi Junction, which is a no-brainer. But we're looking at planning data and sort of the existing buildings that are there to be like, okay, well, based on the current zoning, these areas actually have a lot of space to go higher, whereas some of these ones down in blue, they're kind of built out. So yeah, all in all, just there's a huge amount of data and technology that's running through this company, and yeah, we're really pushing to be on the forefront of what comes next. Thank you.
Great, Pete. Yeah, I think you covered off a lot of different aspects, and really good to learn about Transurban's transport digital twin as well, particularly with all the usages that may have for a company like Transurban as well. Yeah, we'll go next to Megan from the New Zealand market, and covering off some of the stuff that she's been doing around pedestrian planning and various other aspects embedding digital twins as well.
Sorry, just needed to unmute that. Can you see my screen now?
Yeah.
Cool. Okay, yes, so thanks, Casey. Yeah, I'm just going to share a few ways that I use intelligence in transport. And as Casey said, especially regarding active modes, so walking and cycling. And I've also got as much time to spend on the ways I'd like to add more intelligence into our transport systems. And I just start by saying that we tend to think of ITS as maybe this fancy new technology, and there is definitely a lot of that emerging. But I consider part of intelligent transport systems is really taking what we've already got and adapting it in a smarter way that better suits our current needs. So at the start of what we do, we need to collect data, and there's lots of new ITS applications that we can use to do that. So the first photo on the left here is just a GIS field collector app. So we can create maps when we're at the desktop at a layout we want to see, think about the things we want to look at on the field, and then we're out in the field, we can use our phone, add a point, make a note, add a photo, draw some lines, make a measurement, and then it's all waiting there when we get back to the desktop. The middle photo takes that to another level. We've got this 3D printed cart, which is holding a phone, which has some software on there, and so the phone is recording the footage of this path as the cart gets pushed along, and the AI in the software is actually assessing the terrain of the path and using these accessibility metrics to give a rating for accessibility criteria. And the third is another prototype developed by Smart Access. They've developed the software that a vision impaired user could have on their phone and hang their phone around their neck, and as they walk around, the phone is viewing the street in front of them and guiding the person across the street along their trajectory and giving them any warnings about obstacles or challenges that they might face along their way. I think GIS deserves its own mention. We use it a lot in the planning stages over the years, and it just keeps getting smarter. So firstly, as I said, we can use it as a platform for collecting data in the field. We can collate data from lots of different sources and use the GIS to make them talk to each other. We can look at our travel times and therefore catchment areas and optimize the placement of our facilities. We can use it in planning and prioritizing a network once we've got all this information in there, deciding what to deliver and when. And over time, we can look at the trends that are occurring. To improve a few traffic control devices or TCDs, especially traffic signals for cyclists and pedestrians. I think one of our favourite achievements is that we've introduced directional cycle signals. Previously in New Zealand, which I believe is the case in Australia at the moment, we only had one general signal for cyclists, which is analogous to our standard round signal for general traffic. With directional cycle signals, we can control different cycle movements that are coming from the same approach independently, similar to how we use green or red turning arrows for general traffic. So for example, this intersection in the photo, we can see we've got this through cycle movement, and that can operate whenever the parallel traffic is going. But we've also got the diagonal crossing across the intersection, and that can only go when the traffic from all other directions is stopped. So being able to operate these two cycle movements independently gives the through cycle movement a much better level of service, which makes the cyclist more compliant and therefore the intersection operates more safely. Sometimes though, instead of treating cyclists more similarly to motor vehicles, we want to be able to operate the cycle movement a bit more like a pedestrian movement, especially when cyclists are entering or leaving a shared space. So we've also been involved in trialling two aspect cycle signals. So I've just got the red and the green aspects and operates similar to a pedestrian crossing signal. And this gives us again more flexibility in how we cater for cyclists at signalised intersections and crossings. And the recommendation from this is that they be incorporated into a TCD rule at mid-block crossings, but that there's a bit more work and understanding to be done at barn stumps or pedestrian scramble sites. And so further trials are currently underway. And there's a lot more I'd like to see happen in New Zealand and lots we can learn from other countries. Currently here in New Zealand, we rely almost exclusively on fully protected movements for cyclists coming from a separated cycleway, which generally ends up in us giving cyclists a very small proportion of intersection green time, so they get a low level of service and high delays. And I think that we can improve this by operating safe filter turning of vehicles across the cycleway movement in the right context and with the right designs. And since I went on a trip to New York City in 2016, I and SYSTRA have been advocating to trial flashing yellow arrows to remind drivers to turn cautiously after giving way to pedestrians and cyclists that are crossing over a cycleway or a pedestrian crossing. So we've had lots of support from within the industry here, but some resistance at the trial approval level. So we've been focusing on other things recently. And it wasn't until I was doing the preparation for this presentation that I came this example of others from Queensland, where Transport for Main Roads have actually implemented the flashing yellow arrows. I knew there was some for pedestrian protection, but this is quite unique in that it's got a cycleway across there as well. And that's been a really useful case study for us. I think we'll be able to draw a lot on that experience. I understand from the team there I've been in contact with that their context and reasons for doing it was a bit different to what we're dealing with here, but I think there's going to be a lot of good lessons learned coming up from that. The other thing I'd like to do is let small near-side signals for cyclists become a recognised DCD here, because sometimes following the rules for the placement of traffic signals just doesn't work, or doesn't turn out to be the smartest things to do for cycle signals. So for example, this is our only existing small cycle signal site in New Zealand, which is at a cycleway in Auckland. You can see the cycleway goes around the bend, so cyclists aren't going to be looking to the far side of the intersection. They also can't really see the primary signal when they're waiting at the limit line. So by having these small near-side signals, they're able to actually see what's going on for them, make better decisions, and especially avoid conflict with the pedestrians on that crosswalk around the corner. There are lots of places in Europe and the United Kingdom that use small near-side cycle signals, and so I think we could get this done in New Zealand as well. We talked a bit about collecting data at the very start of the project, and I focus now on collecting data about how users behave, which is also something that's especially interesting to us when we're actually trialling a new traffic control device. We want to see how people respond to it. So at the moment, the current technology is really good at telling us who is where when. We can distinguish between different types of users. We can track which way they're going through the intersection. We can get basic details on red light running, which basically comes down to whether or not someone progressed into the intersection during a red or yellow light. And some of the software is starting to give a conflict or a near miss analysis, which is basically trying to identify when users got too close. But often when we're doing these things, we still rely on good old manual tabulation from video footage. And this can be really good because it can help us identify behaviours that we didn't foresee, which is really useful when you're trying to study something new. But another reason that these automated methods haven't really taken off is that the developers are struggling with quite a lot of false positives in terms of near misses. So for example, in this photo here, we could see that if this vehicle turned just in front of the cyclist, then we'd have a big problem. But if it turned just after the cyclist had been through, we'd be less worried. But the software would probably turn both situations up as a near miss because of the timing and the distance involved. So I'd like to be able to drill deeper into things like looking at the type of infringement. So for example, for red light running, rather than just did a vehicle cross the limit line when the light was red, I'd like to know when exactly did this happen in the phase. Was it just after the light had gone red, or had the vehicle been queuing there for a while and maybe they anticipated their light was about to go green and took a head start? Or did they make a false start because they saw someone else's signal and they just reacted to that? And then, very importantly, what did the driver do after they'd made this breach? Did they continue straight through the intersection, perhaps without noticing? Did they actually catch themselves part way and maybe just stop over the pedestrian crosswalk? Or did they perhaps try and reverse back? Because all of those scenarios have a different effect on the actual safety of the intersection and give us a different understanding of why people are making this behaviour. I'd also like to drill into the interactions between users. So we could start by looking at some warning signals. So for example, if this driver here is indicating that they're going to turn left, we can predict which way they're going to go and what effects that could have. We should be looking at the types of parties involved. So here would be car versus cycle. That'd be similar to our flashing yellow arrows if we studied them. Or we might be interested in pedestrians versus cyclists. So for example, in the two-aspect cycle signal bounce dance trials. And we wouldn't be looking just at physical contact or just at near misses, but really are people changing their speed or trajectory to avoid conflict? putting all this together, we can get some sort of level of risk. So rather than just a yes or no, was it a miss, we can look at things on a spectrum of risk. How close do people actually get to colliding? How much did they have to brake or speed up or change their trajectory to avoid collision? And a lot of these things are feasible with the current technology. I know that there's various companies trying to do different aspects, but I just think there needs to be more training and more scenarios applied so that we can really weed out the nuances and be able to use this more extensively. So thanks very much. Happy to talk about this more later on, or with anyone who wants to get in touch.
Thanks, Megan. That was really great. Yeah, very insightful detection technology, as well as the digitization roadmap around active transport. I think there's a lot of companies in Australia as well that are following similar trajectories. Really interesting to learn about what's happening in New Zealand as well. We'll go to our next speaker, Matt, who's from GHD. And Matt will talk a lot about the work that they've been doing on major projects in GHD.
Thanks very much. Good afternoon, everyone. Thank you for giving me the opportunity to be part of this discussion. Yeah, so my name is Matthew Jednick, Digital Delivery Lead for Transport here at GHD. I've worked across, a few major projects recently that do a lot with ITS, and how we integrate design, data, and technology into how we deliver these transport solutions. So a little bit about GHD. We're a 11,000 strong company, global company, and there's about 6,000 in Australia and New Zealand. So we do mainly focus around this region, and we do have input into the different various states. So at GHD, my focus is on ensuring that the information we produce is accurate, connected, and ready for future. Because in transport, it's not just about building roads and rail; it's about building smarter systems that people rely on everyday basis. I'm really looking forward to showing how digital engineering is shaping the way we design, implement, and operate ITS, and how it sets the foundation for connected and intelligent transport networks. So from a digital engineering perspective, intelligent transport systems are not just about adding technology to roads. They're about designing transport infrastructure to be smarter, connected, and future ready from day one. We'll a few of these: so the early integration, data-rich assets, simulation testing, life cycle value, and future outlook. Early integration. Often ITS is treated as an afterthought once the road and rail is completed. But through digital engineering, it allows us to embed the ITS requirements in an earlier in the process itself. In the use of federated models, we can place gantries, ducts, cameras, signage in the right locations, avoiding clashes, reducing rework. This also it means that it evolves together, not just in isolation itself. And yeah, it's really the backbone or cornerstone of how we do our design on an everyday basis now. The assets themselves. One of the biggest benefits is that our models carry data, not just geometry. Every ITS asset we design, a sign, a sensor, CCTV, pole, etc. We can have that metadata attached, power comms, installation details, maintenance requirements. That means that the assets at handover is not just about a drawing, but a fully described digital asset ready to plug into the operator's system, as well as being able to plug directly into the digital twin, which is really the key aspect these days, is how it can then be future-proofed going forward as well. This also gives us the ability to simulate how ITS will perform before we build it. We can model the traffic flows, lane closures, incident responses, even tunnel evacuations, and test how the ITS system, like smart signage or detection sensors, will respond. That reduces design risk and allows more evidence-based decision-making to be done before it gets to the real world. The value in ITS systems is realized over decades of the operation, not just construction. By handing over structured digital data, operators can integrate ITS assets into the SCADA or the traffic management system immediately. This supports predictive maintenance, faster fault detection, and more efficient operations. This ensures that ITS continues to provide value long after the construction is complete, and further integration into the smart ways of delivering and providing service to the public. Future outlook. This one was a little bit hard for me to actually to talk about, purely because of how quickly everything is changing on a day-to-day basis. Things are being made obsolete so quickly. But as a ITS for the backbone and having a connected mobility, it really is about enabling autonomous vehicles, AI-driven traffic optimization, and integrating that across the entire road, rail, and pedestrian networks, active transport network. And I guess all of this really depends on how the design of the digital backbone is done today, like real-time traffic monitoring, dynamic traffic signals, incident detections, where we actually place these assets as well, or your Wi-Fi systems, etc. It's really going to be the cornerstone of how we actually build and maintain and future-proof ourselves, purely because in where we are now, in 5 years' time, it's going to be completely different, I suspect, purely because of just how quickly things are changing. So in closing, so from a digital engineering perspective, ITS is more than technology deployment. Sorry, I've been sick, so I'm trying to not cough. It's about designing smarter infrastructure, creating data-rich assets, and setting up our transport systems to adopt to the future. ITS and digital engineering together are how we move from roads and rail to a truly smart, connected and transport network. Thank you.
Thanks, Matt. Really appreciate your presentation. I think that was really insightful to learn about actual framework being across GHD as well. So next we'll go to Maud, and we'll be focusing in on rail modes in this presentation. Thanks, Maud.
No problem. I'm just trying to share the right screen.
Yeah, all good.
Yeah, let me know if you can see
Yes.
that.
Yes.
Great. Okay. Yeah, so I'll try not to overrun, obviously. So yeah, SYSTRA is an engineering consulting group specialized in public transport and mobility. mobility solutions in general. So we do have a global network with presence in over 80 countries. And our first project in Australia was almost 20 years ago now. So it's been a couple of years we've been working in Australia, and especially in Sydney, Melbourne, and Brisbane. In the space, in terms of planning and design, so we've contributed to a lot of metros and high-speed projects across the world, as a little bit of an overview. So I've tried, in the next slide, I've tried to summarize basically our portfolio and what we do in as part of our department here in Sydney. So yeah, basically when there is a problem, we try to find a solution. I will summarize it like that, but in terms of range of services, and we go, well, we deliver a lot of planning, rail operations, advice, and operational modeling throughout the whole project life cycle. So we use a lot of digital tools to improve the project outcomes, streamline efficiencies. We do a lot in the systems integration space as well to help integrate solutions together. We use a lot of tools. We do work with a lot of engineering disciplines. I think especially my department would be with mostly the signaling teams, rolling stock and maintenance as well. So we need to understand the system as a whole. In terms of operational integration as well, we always try to include the, well, obviously the multimodal kind of network as well. So we don't want to just restrain ourselves to just the rail space. Obviously, it's more than that. So we try to integrate a lot of transport strategies and find some interfaces between modes, I would say. So yeah, a couple of examples here. So we do obviously railway operations and scheduling. We do a little bit of passenger flow and station design. Also freight and logistics optimization. I think it's a very trendy topic at the moment in Australia. So we tend to do a little bit more of these as well. But also, yeah, I just want to show that it can really range to like some actual typical detailed planning, but also we're trying to be innovative. We do some emergency planning as well, risk management. So yeah, we deliver a lot of different solutions. And in terms of key applications for my department, so I've added a couple of little graphs. I hope they're not too scary for you. But yeah, in a day-to-day, on a daily basis, basically what we do, we use some of the software. So one of the software we use the most is SYSTRA, well, timetable planning and simulation tool. So we can basically build a whole timetable in that particular software. We do a lot of capacity analysis on the network, so trying to make sure we can accommodate all the service levels for future and long-term plans, especially for the governments. We can do a whole lot of conflict detection, understanding how to utilize infrastructure the best. We do, yeah, a whole lot of things at platforms, understanding resource utilization in terms of drivers, trains, everything that is very relevant for the operator, obviously. We do also a lot of scenario testing, so that's why it's quite relevant to be able to have access to a software that can do a whole lot of optioneering around, like, yeah, for example, typically for a high-speed project, you have to make sure you find the best alignment, making sure you can achieve like high speed, but also depends on the alignment itself. So not having high gradients on your alignment, making sure you can optimize your rolling stock capacity as well. So it's a whole lot of different components. I'm not going to go through all of them, but I'll go to the next slide. Because so yeah, what I try to do here is having a couple of different examples of what we do on a daily basis. But each one of them is quite relevant because I've been trying to think about how we could potentially optimize further these assessments in the future. and also trying to combine different softwares together, integrate more data in the future, since we've got access to more tools these days. So basically, that's for a single turn-back operation. So we would be using RELSYS because that's where we actually build our timetable. And I have some little videos. I'll try to make sure they work, but basically that's what RELSYS can give you. So you have your track, your infrastructure, and you can have your, as you can see here, your little trains running. And that's actually showing how your trains do like turn back at the terminus station. I think this video is a bit slow, but if I can accelerate it a bit, you'll see, yeah, you'll have different trains in the system, and it's kind of showing you the occupancy and how track occupation will be released. So that's quite manual in a way, but so we have access to that software, but what we try to do is leverage a bit more from that, especially for the client, because clients, they quite like visualization. So we actually managed to do a similar type of modeling with different software, AnyLogic, as you can see on the right. And I think it's it's a lot more visual. So it's, yeah, same type of simulation at a turn back station, but you can actually, on top of that, so you also get visual of the pedestrians at station. And it's pretty cool, like whenever you have to showcase and present some of the outcomes, I think you get access to a wider audience as well. You don't lose everyone in the technical details. So I think that would be one of the first examples. If I go to the next slide, similar thing. So what I want to show here is that we are trying to make sure all the planning's concepts are transferable between the different transport modes. So that's an example that we did at the time for a Hyperloop project. So pretty much, I would say pretty much similar to what we do in rail planning, except, well, obviously it's different stations, different rolling stock, very short headways, very high speeds. So it's all very conceptual kind of system, but yeah, just wanted to show you that we can do very similar things in that space. It's not because it's a different mode that it's a different way to process and the data, and we can use very similar data, but just for a different purpose, especially for that system. So maybe I'll play the video again because I thought it was pretty cool. So it's showing the operation of different cars at terminals, and so you can see you've got like a lot of different platforms there. It's quite a similar approach to autonomous vehicles. And for this particular assessment, we use VSIM, which is normally a road traffic simulation software. I'll go to the next. So I'm just conscious of time. Let me know when I need to conclude. This one is a yard modeling, so similar type of assessment. And we use AnyLogic, so one of the previous software I talked to you about. We try to optimize some maintenance activities. So the software was actually helping us a lot with the optimizations themselves. Like we saved a lot of time on automation. The client was a big fan of the visuals, as you can see here. It was easy to identify the bottlenecks. So if we had to use some kind of spreadsheet or different software, it would have taken us like twice as much time as what we actually delivered. So it was pretty good. I think we can definitely reuse this approach in the future as well to deliver other types of projects. But this was quite innovative at the time. So we had to define everything from scratch. There was no other project we could focus our analysis from. So I'll go to the next slide. More videos to come. So this one is more around, again, using AnyLogic, but at a platform. So it's showing crowding models at stations. These little graphs at the top here, I think it's trying to show the interface between passengers at stations and how we can actually find a way to interface that with our train distance graph. That's more like a static way to build a timetable, but we are thinking there might be a way of showing the passengers' flows on top of these train paths. So that's the little graph you can see at the top right. Basically, it's just very interesting to understand the impact on dwells, but it's going to impact your timetable, passengers' flows at stations, so it can be optimized within the station design. We do a whole lot of also emergency evacuation appraisals. So it's just very, very interesting to understand what's the best operational responses in case of any, failure incident on the network. And that's last example. They did quite a lot of that in Paris at the time of the Olympics as well. So it's very relevant here. And then last one, I don't have any videos for that one, unfortunately. But this one was more another study that we did, trying to understand how we can link asset performance and service delivery on the network. So typically, from our RLC software, we could try and evaluate what's the runtime running on the network, which is usually a metric that Sydney Trains would be using. Sydney Trains is just an example, but as an operator, you want to know how many trains are late on your network and how well your services are delivered on the network, obviously. But then we're trying to understand how the asset performance is impacting that particular metric, because asset performance is not something you can really define in RLCs as well. So we did another type of model trying to understand the correlation between the two. I thought it was pretty interesting because we could have a look at future strategies and investments. There's a whole lot of punctuality data analysis from which you can extract different KPIs and contributors to the delay. So I think that's some of the graphs I have here. It's trying to understand why your network is not managing the way you want it to perform, is not managed the way you want it to perform. So that's another way of doing that. And last one is around making sure we also take into account the customer feedback and do a lot of customer survey, trying to understand how we can integrate that back into the models. So I've listed here some of our key challenges. Obviously, probably don't have time to go through all of them, but as I think you understood most of our challenges through these little examples I've just shown you. It's a lot about data processing, making sure we've got compatibility between different softwares, can find faster ways of delivering things for our clients, and also communicating with nice visualizations. I think is quite an important one. Thanks for listening. And if you want to know more about SYSTRA, obviously, I'm happy to tell you a bit more. But that was it. 12:55. We've got 5 minutes left.
Well, that was really good. I mean, very rich presentation. Really appreciate your intelligence there and sharing of that knowledge as well. Considering the time, we've got 5 minutes. Maybe I'll just pose a couple of questions, and if the audience has any questions, feel free to put them in the Q&A, as I mentioned already. Maybe I'll just quickly start off with the panel. In terms of digitization and implementing technologies, I guess what are the main barriers that you're seeing being sort of addressed across the board? Because is it I guess the lack of investment dollars? Is it the lack of understanding of the benefits, or is it more the clouded nature of technology and failures in technology, historical overspending and so on and so forth? What are the key issues that you're seeing from your clients, from your organizations, in terms of implementation of technology solutions? Anyone can jump in and just start answering.
I think on our side, I think the inhibitor for us is almost a complexity argument at times. So
Yeah.
you know, the more data you have, the more systems that are available to you, the amount of complexity to manage that, I think, rises quite substantially. And you know, we're often embarking on a lot of different things, but to get it working effectively, you almost need to deploy, in a way, a bit of a startup-y sort of nature. That's sort of how we found it, where it's not about getting it perfect necessarily straight away. And you know, we've got engineers and data scientists all throughout the company, and there's often a habit that we want to get right and perfect the first time with every bell and whistle. But the risk of that is that it never actually gets completed because you've just taken on too much complexity. And then that obviously feeds up to management, and then they suddenly don't see the value. So I think to get over the complexity, my 2 cents is that you almost want to simplify it at first. If you really want to bring in technology and make it work well, get something to market quickly, whether it's in the company, and try to iterate on that. Otherwise, you just get caught in a bit of a complexity trap.
Yep. Yep.
I'd say also keep investing in the innovation space, because sometimes you're really prisoner in terms of, you know, like the tools you've got access to, and you can only use a couple of them, which you're familiar with, obviously, and they're well known on in the industry. But yeah, you're just lacking time and resources and, you know, innovation in that space to be able to find some optimization, basically.
Megan and Matt, do you want to add anything to that?
Yeah, I'll say pretty much all of the above with what you originally said. But definitely want to tack on to Maud's. So there's not one software out there that can actually do all the tasks that you need to do, and it's very difficult to really, I guess, showcase all the things that you want to in the project and what the team want to provide, being able to actually present that, I guess, to the industry. The other part is that it's definitely a cost factor from our perspective, from a more of a design aspect. You have X amount of dollars to get something off the ground. There's lots of things that we can do and make work, but they are there is always a cost to benefit analysis that you have to do on that part. So it's making 100% right, Pete. It's getting something out there to start off with, and then they probably have to come back and then keep building on that element.
Yep, I agree. I think it's an investment hurdle at the moment. We sort of know things could be done. We've got an idea of how to go about that, but there would still be that initial investment of time and resources and money to make that happen. So we sort of stick with what we know and have been doing for a while.
But thanks everyone. It's 1 o'clock now. So we'll just do a quick wrap up. Robin, if you want to also give your closing remarks as well. But yeah, Smart Cities Council is really committed to doing these kind of events. If anyone's interested in participating, feel free to get in touch with myself or Robin. We really thank the speakers today as well for sharing all their insights and taking the time out not only to come today, but to prepare all the packs and do all the pre-briefings as well. Really, really highly appreciate that. And if there's anything, I'm sure they'll be happy to answer any questions. You can probably reach out to them directly as well in the future. But yeah, I'll hand over to Robin to give the closing remarks.
Thanks so much, Casey. Really just want to say a big thank you to Casey for putting together this incredible group, and to all our speakers for the hard work in prepping and sharing such great content. So really looking forward to hearing from you all again, and hope that this becomes a solid series and we can revisit some of these presentations and see what progress you're making. But massive thank you to you all, and look forward to seeing you again soon.